Hello friends, welcome to UGC EPG program. I am Dr. L. Mirana Devi from Department of Geography, Syed Bhagat Singh Evening College, University of Delhi. Today we are going to speak on impact of anthropogenic interventions in surface water storage system. After studying this lesson, students will be able to describe anthropogenic interventions and their impact on water storage system and stabilize the relationship between anthropogenic activities and process of water storage system. What is the role of water in the Anthropocene? Mankind activities gradually grew into a significant geological morphological force during the Holocene. The post-glacial geological impulse of the past 10 to 12,000 years ago in the later part of the 18th century on the planet Earth. Due to human activities, atmosphere and its environment started changing. Ecologists Eugene F. Thomas subsequently used term Anthropocene with different scene in 1980. The term was widely used in 2000s by atmospheric chemist Paul J. Cruzens. Later in January 2016, report on the climate, biological and geological signature of the human activities in sediment and ice cover suggested the era since the mid-20th century should be recognized as geological impulse from Holocene. The term Anthropocene reflects the increasing large number of human activities and interference in natural environment in bringing about global environmental change. Human being has begun the modification of terrestrial water cycle by interrupting rivers flow from highlands to the sea and through land cover change by altering the water vapors flow from the land to the atmosphere. Now, impacts on human activities on water resource system can be considered of global significance for future evolutions of all living species. Evolutions of industrialization has been called the period of Anthropocene because humans have altered the planet Earth natural resource. Example, scarcity of natural resource, that is scarcity of water resources and dissipating water bodies during these periods. Importance of water resources, water in a basic need to the importance of water resources, water is a basic need to all other living organisms including planet life. In fact, the human body is mostly made up of water. The availability of surface water and its quality and quantity play a very essential role in the storage and recharging process of water resources. It plays a major role to regulate the local to global climate, weather and ecological system of the earth. Global water use has grown more or less exponentially with human populations and economic development over the industrial era because of the interactions of all the components of the environments between atmosphere, lithospheres, hydrospheres, biospheres and the consistency of the global water cycle. Any change or modification in one of these spheres will consequently lead to a modifications of the hydrological cycle and water balance. In this context, human activities play a special role. As a part of the biosphere, it massively influences our spray, especially through water consumption and influencing the global hydrosphere. The demand for global water is expected to increase in all sectors by rapidly growing populations. By 2030, the world is projected to face 40% global water deficit according to UN 2016. There are number of reasons for the increasing water scarcity. Increasing urbanization is causing specific and often highly localized pressures on freshwater resources. Globally, 75% withdrawn of water is for agriculture and energy productions, which currently account for 15% of the world are expected to increase by 20% through 2035. According to WWAP reports 2015 and 2017, increasing industrial productions will lead to increased water use with potential impacts on the water quality and quantity at local to global scale. Because of the complex biophysical and chemical properties of water, it does not only serve humans as a source of food but also as a means of production in agriculture, forestry, industry, energy and as a means of transport. The process of water storage system, surface water and groundwater interactions. Understanding the process and mechanism of surface water storage system and interactions with groundwater is very essential. Surface water storage includes water accumulated in the soil surface or underground, intercepted water, that is, the rainfall quantity retained by vegetation cover, and water retained in flooded plains, lakes, swamps, pools, etc. Precipitation in different form and in general true rain on the surface of the earth can be stored in river, lakes, ponds and penetrate into the soil. When the water levels will rise, it will transport to downstream to percolate in the soil, and some amount will evaporate and stored in the atmosphere in the form of water vapor. Surface water is very important for storage of water to regulate water cycle. Rainwater can also be stored into the ground, which depend upon the geological structure of the rock and pores and particles size of the soil. Surface water diversions and change the water storage system in aquifers and water bodies will affect the water discharging capacity of the surface and water cycle. Direct or indirect modification of natural interactions by various anthropogenic activities along the stream, rivers, water bodies, and changing precipitation pattern can change the interactions between surface and groundwater storage system. Example, contaminated aquifers which discharge the stream can result in long-term contaminations of surface water. The present information and knowledge about their process and mechanism is very limited. The groundwater have interactions with all types and surface water resources, that is, river, streams, wetlands in landscape from high mountain to coastal to the oceans, and maintain the availability of water on the surface. The movements of the circulation of the water in the atmosphere and terrestrial environment is very easy to visualize but cannot be possible to visualize groundwater storage system. Surface water comes from precipitations, infiltrations through the unsaturated zone. Distribution is highly variable with space and time. Evaporations and transpiration process return water to the atmospheres. Evaporation and transpiration rate vary considerably according to climatic conditions, topographic and geological features. As a result, the precipitation never reaches the ocean, has surface and surface runoff before the water is returned to the atmosphere. Surface and groundwater interface. Shallow groundwater is more susceptible to contaminations by human sources and activities. Geological features in the surface bed affect seepage pattern. That is, sand inflow seepage is greater at the shorelines and it decreases in a non-linear pattern away from the shoreline. In the figures, we can see the underground water recharge and seepage system and water flow diagram. The fact that the quantity of discharge is equal between any two flow lines. Therefore, the closer flow lines indicate greater discharge per unit of bottom areas. Changing meteorological conditions also strongly affect water storage system in surface water beds near the shorelines. Groundwater flow paths vary greatly in length, depth, travel time from points of recharge to point of discharge in the groundwater system. Due to the strong interface between surface water and groundwater, the recharge system between surface and groundwater is affected by the environmental conditions, human activities on the land surface and in the upstream and catchment area. Anthropogenic interventions in surface water storage system, human activities are impacting the available global water resource system. Until the industrial revolutions, human activities play an insignificant role in influencing the dynamic of Earth system. Now, the relations between humanity and water resource is continuously changing since the period of industrial revolutions. But presently, human beings and their activities exceed nature in terms of changing the biospheres and affecting all other aspects of Earth functioning system. There are a number of reasons for increasing human interventions in surface water storage system. The history of Earth formations, which formed around 4.5 billion years ago has seen many immense biological, geological and cultural events. Human interventions in the nature are increasing day by day, especially after agricultural revolutions and industrial revolutions. In the most recent part of the Holocene, anthropogenic impact become much more extensive. In the second half of the 20th century, humans are shifted from rural to highly urban populations, agricultural industrializations by green revolutions and increasing pressures of chemical exploiting surface and groundwater resources, uncontrolled use of pesticides and increase in the rate of fossil fuels consumptions. There is a long list of human activities and their impact on the water system of the Earth's surface. Following are the measures human interventions for terrestrial water storage system. Number 1. Construction of engineering structure to control water flow for water resource management. Construction of engineering water structure is responsible for diversion of water from one part of the hydrological cycles to another, These human modifications in nature's environments leads towards the reduction or increase in natural hydrological fluxes. Underground water is a major source for humans' needs and activities like irrigations and drinking in the arid and semi-arid regions. The natural rate of water recharge to aquifers are very slow in the arid and semi-arid regions. When the rate of extraction of water is increasing, it will transfer from aquifer to the atmosphere. The regions will deplete the continental water storage and temporarily increase water vapors in atmospheres through enhanced evaporation flux. Secondly, diversion of surface water for irrigation purposes internally draining basins of arid and other regions increase the rate of evaporation and loss of surface water. Number 2, land use practices. Land use practices are assumed to have important impact on both the availability and quality of water resources. Land use practices will directly or indirectly impact it in both positive and negative manners, not only to the people living in the peripheries but also the people living in the downstream regions. Improved land management practices are helpful to regulate water storage system, but on other hand side, inadequate land use on the water resources might not only be felt by water users who cause them, but also by others who have some association with this area. Different land use practices affect hydrologic regime and water quality. The groundwater recharge may be increased or decreased as a result of changing land use practices. Number 3. Irrigations and extraction of groundwater. Withdrawal of groundwater from shallow aquifers for various human uses can reduce the availability of the surface water and storage system. Extraction of groundwater, over pumping and unscientific irrigation system has significant impacts on the surface water in different regions. Following are the main causes for high amount of extraction of underground waters are: Number 1. Unregulated access to groundwater sources, affordable small electric and diesel pump, irrigation requirement for agriculture, free availability of water in the nature, subsidized electricity and fossil fuels have led over pumping of groundwaters for irrigations. Rapid growth for urbanizations is increasing excessive groundwater extraction and has depleting water tables and causing land subsidence. A large number of the rivers, lakes and inlands sea are drying due to the high amount of withdrawal of underground water. The main consequence of unlimited withdrawal of waters are depleting water tables, drilling of deeper wells and depletion of water resources. Number 4. Development of intensive agricultural developments all over the globe has been major cause for changing water storage system by anthropogenic modifications and changing in land use cover. Demand for agricultural water is proportionally increasing with increasing the demand for food. Increasing tillage activities on the land surface has changed the infiltrations and runoff aspect of water surface and affects the water recharge capacity of underground waters, hydrological cycle and evapotranspirations. High amount of irrigations, facilities for longer durations in the field for crop cultivations and use of chemical fertilizers, pesticide, insecticide are affecting the surface and groundwater interaction and storage system. By using these chemical applications, water is contaminated by various points and non-points polluted, which is available in soil, water, air. As a result of natural process or through mechanisms of displacement and dispersions of anthropogenic activity, it impacts the water storage system. Number 5. Construction of dams and reservoirs. Construction of dams for flood control, irrigations, drinking, hydropowers and other various purposes is also affecting water storage system. Diversion of water channel from their natural flow system by construction of hydropower and irrigation dam lead to deplete the natural water recharge system. Dams building, on the other hand, impounds continental runoff that would otherwise have been stored in the oceans. Anthropogenic activities have resulted in the partitioning of water between that stored on the continents and in the oceans, leading to change in sea level. The balance between these negative and positive alternations can be used as a measure of net anthropogenic disturbance to the global hydrological cycle and water storage system. Number 6. Soil erosion. Soil erosion is eroded by different tillage practices and flood irrigations for agriculture, production and different mining and quarrying activities. This is highly susceptible to soil erosion and it changes the relationship and interface of surface water and groundwater chains in relief through erosion of uplands and deposition in valley bottoms can produce change in hydraulic gradients, which in turn determines the rate of base flow and net water storage. Number 7. Changes to the surface of earth. Forests are the major storehouse of water in both the soil and living tissue. Increasing deforestation directly affects the hydrological cycle, removing of vegetation cover and overgrazing and plant are not there to intercept rainfall. The pathway of water cycle is shifted from infiltrations and groundwater discharge to runoff and water run to the stream on river almost immediately. Increased runoff necessary means less infiltration and therefore less evapotranspiration and slow groundwater recharge. Lower evapotranspiration means less moisture for local rainfall and results less surface water and groundwater may be insufficient to recharge. Soil waters in the shallow root zone following disturbance in soil reduce. Barren land where rate of deforestation is highly lead to increased runoff, which is not stored in the aquifer and will yield lower evapotranspirations and may elevate groundwater tables as per the availability of soil quality. Deforestation also reduces the cycling rate of water between plant canopies and the atmosphere and thereby affect the climate system. Number 8. Impact of anthropogenic interventions in surface water storage system. Fresh water constitutes only 2.5% of the total available water on earth and 2/3 of the fresh water is located in glaciers and ice caps. 0.77% of all water is held in aquifers, soil, pores, lakes, swamps, rivers, plants life and in the atmosphere. Water is renewable through hydrological cycle which is based on solar powers and gravitational forces. Underground water can be tapped but underground water is rapidly declined due to subsidized electricity which increases the rate of extraction of underground water. It depletes the underground water in higher rate and disconnects the surface and groundwater hydrology. The hydrological cycle play a major central role in the atmospheric process of the planet Earth. Mountains historical evidence to impact the hydrological cycle is global warming and climate changes. It impacts the land-based water cycle system and absorbing many changes and recent issue of affecting water storage system. Number 9. Draining wetlands and loss of wildlife habitats. Wetlands play an important role in the hydrological cycle. Wetlands function to store and release water in similar manner as groundwater reservoirs. Various anthropogenic and natural activities drain the water stored in the lake or in the forms of soil moisture and water storage in plants. Large number of industrial and housing development projects have drained off or filled natural wetlands. The storage water system will be lost by various human developmental activities. The destruction of wetlands has the same impact as discussed in the removal of vegetation and groundwater. Number 10. Desertifications. Drying of marginal soil due to overgrazing and other intensive land use on arid or semi-arid soil lead to net loss of water, reductions in evaporations and increased storm runoff. Desertification refers to expansion of desert or desert-like condition into adjacent area due to scarcity of water. This is due to combined impact of adverse climate conditions and human interventions in the natural water resources. Some of the world's largest rivers do not reach the sea because large amount of reductions in surface water and drying up of streams and ponds. Number 11. Impacts on estuaries. Diverting rivers' water in different directions to their natural flow to the sea has seriously impacts in estuaries, bays and rivers in which fresh water from a rivers mixes with seawater. Estuaries are most productive ecosystem of the planet Earth. They are rich in breeding ground for many species of fish and waterfowl. The shell concentration is increasing by diverting river flow to utilize for irrigation purposes and affecting the estuary ecologies. Number 12. Groundwater depletions and groundwater pollutions. The water table may rise as a reason of decreased evapotranspirations. Example, following lodging of conversions of forest to grassland for grazing. Research may also decrease due to an increase in filtration rate. Example, through afforestation of degraded areas. In contrast, the water tables may fall as a result of decreased soil infiltrations. Example, through non-conservation farming techniques and compactions. Number 13. Diminishing surface water and land subsidence. High rate of extraction of groundwater withdrawal is lead for falling water tables and depleting water resources and diminishing surface water. As water table drop, spring and seep dry up as well, diminishing even stream and river to the points of dryness. When the water tables drop, the rate of land subsidence is also increasing because over the years, groundwater has least cavities in the ground where these spaces are filled with water. The water helps to support the overlying rock and soil, but the support is lost when the water tables drops. When it happens in the city, underground pipe break, causing leak and wastage of domestic water, and sewage pipe can also fracture, contaminating the groundwater's aquifers. Sinkhole is also another kind of land subsidence developed when has underground caverns drained of its supporting groundwater suddenly collapse. Number 14. Change in self-purified capacity of water discharge. Discharging of industry influence in the surface water and stream pollutes water resources. Increasing mining and quarries activities is also affecting the water resource. This drastic consequence of such situations may affect the lives of human and hydrological cycle. These industrial activities hamper self-purified capacity of water discharging. Large number of industrial activities directly or indirectly lead to modification of river channel, which can in turn induce changes to aquatic environments. Some of the changes to the river system include change to depth and width for navigation, creations of flood control. Number 15. Salinity and salinizations. An increasing salinity of surface and groundwater can have detrimental effect on downstream water uses. High amount of irrigations for a longer period of time for crop productions in the agricultural sphere accelerate the accumulation of salt through evaporations. Excess infiltrations from the irrigated area causes the underlying groundwater level to rise and produces water lodging in poorly drained soil. When the water level is close to the Earth's surface, capillary actions allowed water to rise further and evaporate from the land surface, resulting in salinization of soil and water. The impact of land use on salinity depends on climatic as well as geological factors. Irrigation and drainage activities may lead to increased salinity of surface and groundwater as a consequence of evaporation and leaching of the salt from soil. This is one of the special concerns in arid regions where such surface drainage water always has high salt concentration and increased hardness and higher sodium absorption ratio than the supply water. Salt water intrusions. Salt water intrusions is another impact of human interventions in water storage system. Along a coastal regions, when the water tables goes below normal due to the excessive extraction of groundwater, the normal interface between fresh water and saline groundwater moves inland. This causes salt water intrusions which pollute the groundwater, making it usable for drinking as well as irrigations. Number 17. Change in water balance and climate change. Climate change is most recent factor expected to additional effect on water storage system. Study conducted by Netherlands in 2014 indicated that the impact of man-made reservoirs and water withdrawals from the long-term global terrestrial water balance is small, but in a small river basins level, land impacts of human interventions are significant. Netherlands in 2014 also observed that in Asia and United States, the effect of human interventions exceeds the impact expected for moderate levels of global warming. Increasing in greenhouse gases, Earth climate is becoming warming and hydrological cycle and surface water is being altered. Increasing global temperatures means more evaporations from the land surface, vegetation, soil and water bodies because evaporation increases exponentially with temperatures. Now let us conclude. Currently, every corner of the world is facing serious and alarming problem of global water crisis. The characters of renewability of water resources are possible only if water can be used wisely and managed properly without changing the biophysical and chemical properties of water. Otherwise, this resource can be considered as non-renewable. In everyday life, we can observe many signatures in the widespread increasing incidence of water scarcity, water use conflict, depletion of groundwater, and drying of surface water resources. The process and mechanism of water storage system are not regulating properly. Environmental natural processes are changing by human interventions, and rate of environmental degradations and amount of water pollutants are increasing and changing water storage system proportionally with human economic development. Now, people and communities are experiencing the direct and indirect impacts of water crisis on their lives, health and livelihood. Thank you.